Hello and welcome everybody. Thank you for joining us today. My name is Jason and it's my pleasure to introduce today Andrew Hill from Textile. Today Andrew will be taking us through the Textile Buckets Masterclass. And with that, Andrew, do you want to take over?
Sure. Good morning again, everybody. I'd imagine that there's a few people watching today's session that were also part of Monday's session on the Power Gate. Today, I'm going to present something very related to Power Gate, but a totally different technology. And we'll actually play with it a bit, and I'll show you how it leverages Power Gate over an API that's built on Filecoin. So if you didn't watch that masterclass on Introduction to the Power Gate, definitely recommend reviewing it. Just a quick summary there. The Power Gate is actually a technology built to integrate into systems that want to use Filecoin for data storage. And so it does a lot of things for deal management, wallet management, deal lifecycle management, and doesn't have strong opinions about what applications you build on top of it. It's really meant to build into systems that already have user models, security models, all of their own ideas, and then just layer that on top of Filecoin-based storage. One really good example of that is the Textile Hub, which is an API and platform that we build, and we'll use that a little bit today. And so you'll actually see Filecoin APIs enabled through the Hub and with buckets that are actually coming from PowerGate. They will feel slightly different from PowerGate because they're just enabling the model of the Hub. And that's really the power of PowerGate, and other products like that could build it into it. So Buckets has more of an opinion about how you store data, and that opinion comes from our work with IPFS in the past and how what are some of the difficult pieces for developers to figure out in IPFS, and our thinking about how to make that easier. And so let's take a look at Buckets and start playing with them. And I think that the reason why a lot of people will be on this call is they want to know how to use Filecoin. And one of the really cool things about Buckets is we built it to make some things in IPFS easier and more intuitive for developers. But at the same time, we continued that development, and now it's one of the easiest ways to use Filecoin. And it will be for sure one of the easiest ways to use Filecoin for developers come mainnet. So what are buckets? I'm going to start at the beginning, and I'm going to show you kind of the things it solves in the IPFS network, and then I'm going to jump into Filecoin, which is literally one extra command when you're building things, which is pretty cool. So buckets are dynamic directories stored and synchronized over IPFS. They build on IPFS. They build on another technology we created called Threads, and for Filecoin capabilities, they build on the PowerGate. When you use buckets, if you've used, say, Amazon S3, the remote nature of buckets should feel very familiar. If you've used a command line locally to manage folders and directories, it's all the same. And so you'll take a look today, and we'll create a bucket in a folder locally, and then we'll push that to remote IPFS nodes. Buckets really helps with the synchronization and persistence of folders on IPFS, and it does that by using the internal structure of data in IPFS, the DAG, to help you figure out what data you need to move to different peers without having to consume new bandwidth. So it actually does diffing locally and pushes just the things that need to change. And then it has a lot of really useful features so that you can think, I have a directory, or I have a folder, and that's all I need to know. And then all the sort of magic of IPFS just kind of works underneath the hood, and you don't have to do a lot of address and CID management and all that stuff. It just kind of is wrapped into there, and you can think, I've got a folder. Oop, bucket strengths, great. I didn't finish that, but I put it into other slides, don't worry. So the strengths of IPFS really, or sorry, the strengths of buckets really comes down to the way that it can track and move your data over IPFS efficiently and intuitively. And so we have a really nice blog post on the Textile blog about how this is done, the technical pieces of how this is done. But I think a really cool piece to kind of showcase here is how it's moving data. So when you create a folder on your desktop and then you initialize it as a bucket, that's going to be one command. The first step that buckets will do is it's actually going to start calculating the DAG. So the structure of that data, the graph of that data, in a way that IPFS knows how to communicate. So the DAG breaks up your directory, it breaks up each of the files into these pieces with their persistent identifiers. And that DAG, in IPFS world, that DAG never changes. So it has an address, and every time you want to reference that directory, you would use this identifier. But if you ever change that directory, the identifier changes. And so that's one of the pieces that Bucket sort of simplifies, because you don't always have to care about what that changed ID is. You just keep changing your folder, and you can always go back and get the identifier for the current state if you need the CID. But so when you create a folder, one of the things you're going to do is you're probably going to push it to other peers on the network, because the benefit of buckets is really data that you want to move across the network. If you just want folders on your desktop, you would not use buckets. But if you want folders on your desktop that you either synchronize with collaborators, or you push to nodes that are going to keep that data live on the network, or you're going to push to nodes that are going to snapshot that data in Filecoin, you need to move data. And when you move data the first time, that's easy. We do that all the time. But when you move data the second time, you can add efficiency here by not moving data that you've moved before. And Buckets does this by using that internal structure, the DAG, used in IPFS, to calculate only the pieces that have changed. So if I have a bucket, I push it, and then I change a file within it, it will recalculate the DAG and only look at the changed nodes within the DAG and push those changes to remote. So it can very efficiently move and change the state of these folders for your peers or for these remote services that you're pushing data to. I keep mentioning that you push data to other places. Buckets are really good for managing IPFS data that's going to be in multiple places. And so if you've built on IPFS before, this is a pretty common pattern. You've probably used pinning services to do this in a simple way. But Buckets does this, and it kind of gets all the advantages that I've been pointing out of diffing and synchronization and ID management and all of that just in this nice simple API. And so one place that you can push your buckets to is I mentioned before, the Textile Hub. This is our hosted API that knows how to speak buckets. So you can go grab an account on the hub, and then you'll get an API key. And with that API key, you can start pushing your buckets there. Why would you want to push your buckets there? Well, one of the biggest reasons you want to push your buckets there is because the data that you're creating locally on your computer, you might want it to also be available on the IPFS network. And IPFS is great that way. People could pull it directly from your local computer, but the moment that you close your laptop, the network is going to have a hard time finding that data ever again if nobody else is persisting it or nobody else is replicating it. And so the hub provides that for you. And so you can push these buckets and you can push these diffs to the hub in order to have a remote IPFS node also hosting it and publishing that data. Technically, you can think of buckets as sort of a wrapped layers of protocols that make all this pretty simple. And so the protocols themselves are pretty complex actually, but you don't really have to know all of them in depth in order to use the tools to start moving data across the network. It's the same thing like really great protocols can be pretty layered and pretty complicated, but you don't have to know every piece of it in order to get a nice simple UI at the end. And so you can think of that like putting a domain name in your browser and pressing enter. It goes through many steps to kind of move through the layers of the protocols to find you the content that you want. And so Buckets provides that kind of simple UI on top of this stack of protocols in the same way. And so the stack is like at the center is really IPFS and all the protocols that are packed inside of IPFS. And then around that, we have a protocol called Threads. This is our you can think of it like our database protocol on IPFS. And this helps us with moving data and permissioning data across peers. And then finally, we have Buckets and the Buckets APIs for moving sort of binary data that's associated with these databases. But again, you don't have to know each of those things. You don't have to know them in depth, but that's just kind of the map of what's happening. And so then when you push data to remote peers, it can take advantage of all of these protocols in order to get it there. And actually it can take advantage of all these protocols so that you can build it into other things or get it back out, which is really cool. So you can use the CIDs of IPFS. You can actually use the persistent identifiers of IPNS. You can use the Threads database to treat these synchronized data sets as collections in a database. You can use the permissioning of that database to share specific paths within your folders and lots of other good stuff. It's like we were having a discussion yesterday about how much our documentation actually lags behind the features that are available because this stuff has been coming online so fast and is so cool. But we're catching up with it, and so you'll have to dig in a bit to find all the magical pieces. But there's a lot there. The documentation goes pretty far as getting you grounded, and so you can kind of navigate all this. But then you can dig in further and find a lot of really neat features. I mentioned that it's this stack of protocols, and you can and it sort of will use those protocols to move data, but you can also use those protocols to get data back out. And so the data in your buckets is available over Threads. You can every bucket you create will, especially when you're using the hub, you can create buckets and they'll give you a DNS endpoint for it's a subdomain for always grabbing the latest version of the bucket. You can use the IPFS CIDs to do things like snapshotting of your bucket or pushing those CIDs to Filecoin, which is what we'll look at today. You can use the IPNS addresses. And then most recently, there's this final layer of protocols that is supported by Buckets, and that's archiving buckets to Filecoin. So this piece of Buckets isn't really designed to run fully locally. If you check out the PowerGate masterclass 2 days ago with the video online, you'll see that what we've designed is actually a set of Filecoin services inside the PowerGate that's really meant to run in hosted or long-running systems. And so with Buckets, the support for archiving buckets to Filecoin is done by pushing your bucket to the Textile Hub and saying archive the snapshot of that. And that moment in time will grab the CID from IPFS, the exact current state of that bucket, and create a deal for it on Filecoin. And what's really cool about this, I think, there's a lot of things I really like about doing like this idea for using Filecoin. But one of the really cool things that I think is hidden in here is the way it actually will let you rethink your relationship with an API. Because at the end of the day, the Textile Hub is a set of APIs, and for the last 20 years of APIs, they've really been sort of a wall that you can't see over. And so you push data or you pull data from an API, but that you are stuck in that relationship. And with this archiving component of Buckets, you can use the Buckets technology and all the protocols within it, and you can lean on the Textile Hub APIs to get scaling, to get access, to get offline data, and now you can use it to get Filecoin. But at the same moment, when you create deals on Filecoin for your buckets, you can take the metadata for those deals and leave the Textile Hub API. You never have to come back to it. You could go to the Filecoin network directly and always get your data back out, which is very cool in that we've disintermediated our own service from between you and your data, which is in my mind the right way to imagine the future of APIs. Make them available to help you scale and build your applications quickly, but then get them out of the way as far as owning your data or blocking you from getting your data in the future. This is your data, and I think Filecoin is really the way to make sure that you'll always have it. So Buckets already have pretty broad language and platform support. The command line tool that we'll use today is the one bundled with the Hub command line tool. There's also there's also a standalone Buckets-based command line tool and daemon that you can run locally, but we're not going to get into that today. And those are all built for all major platforms. And then language-based support, we have things in Go. Everything is at Textile is written primarily in Go as the first place, and so really complete support over in Go-based things. So you can use the library directly. You can use the client to do things over the API, and then in JavaScript we have the client libraries that you can build things on Buckets. And when you're using Buckets over the Hub API, these can be all permissioned. So it can be you as a developer, or you can create API keys to then create Buckets on behalf of your users, your end users. And Buckets all user models on the Hub have a Filecoin address. And so that address, you can use it as a developer, your own address, or again, you can create users in your application, and each of those users will get their own address with their own balances, and they can be creating buckets over APIs, or you can store data in your app for these users in their own buckets, and then give them the ability to fund and create deals on Filecoin to archive their data or put their data on this decentralized network. And the methods to use buckets are available in all those languages. Here's a couple examples. We'll play with the first one today, which is using the command line tool. There's just a stripped down pure Buck based CLI as well, but again, we'll use the Buck services available in the Hub CLI. That's the first example. Second example is a Go based example, and then finally doing the same thing in JavaScript. So just pushing a file or pushing a directory. There's a bunch of different features in Buckets that as you start digging around and navigating and figuring out how to use them, you can kind of lean on each of these depending on what you need, and depending on what the needs in your app are. You might come and try Buckets for these different reasons. Dynamic data on IPFS it comes with challenges because of that, it's sort of like a mind change in thinking about content addresses, CIDs, that are static. You can never change the data behind a CID. So when you're moving folders and dynamic data, you have to constantly be managing these CIDs, and Buckets really helps you out with that. Multi-protocol, I already mentioned. The API on the Hub will get you really far, really fast for free. And then this is one of the first APIs to be integrated with Filecoin. And so it's already ready to start testing today. And then obviously when mainnet launches, hopefully we'll have really worked out all the kinks and made this a really awesome production API from day one. And one thing I think we'll touch on just quickly if I have time today are the path-based permissions, which are really sweet, which is basically you can create encrypted buckets and then push role-based permissions to remote peers that then will tell them how to expose the data within that path. And you can do that based on other people's public keys, or you can do it based on tokens. And we'll do it with a token today, just as a quick example. And then finally, it's open source and peer-to-peer. So you don't have to use the Textile Hub, though that's what we'll do today. It's kind of the easiest place to get started and ramp up. But you can also check out the pure bucket implementations and how to connect your own bucket nodes any way you like. So with that, I'm going to jump into the actual kind of tour of the technology now and show you how to do some cool things. The last thing I want to note in these slides is where to find us. If you are part of the Filecoin Slack already, you can find us in the Bucket users channel, and we're there to support you and answer any questions, give you feedback, debug things with you. Or if you're, and then a reminder, if you were part of the masterclass on Monday, we also have a PowerGate users channel. So for people going straight to PowerGate, you can come find us there. And then we're going to have weekly office hours as well. I forget when ours is this week, but I think it's tomorrow. So just look out for the Filecoin Slack announcements about office hours and find me there, I think tomorrow. So with that, why don't we jump over to doing some things. So as always, I think the first thing to do is point out that you can find everything I'm going to do today written up in our documentation. And so if you just go to docs.textile.io, you can go into the getting started. You can learn about the Hub account setup, installation, and then you can dig into buckets in particular. And from later in the workshop, we'll do some archiving. And so here are the details on archiving. So definitely bookmark that page because it will be very helpful. So the first thing we need to do is we need to install the command line tool to start working with buckets. There's a few different ways to install the command line tool. Both of them involve going to the GitHub page for the client, and this is all written up in the account. In the installation and setup section as well. But the two ways that you can install the Hub CLI, one is you can go to the releases page, and you can download the appropriate binary. These ones are all the buckd, buck, hubd. All of those are not for today, and you don't need to really worry about them until you get pretty deep. But the only thing that you need for today is one of these builds for the Hub, and this is the Hub CLI. So we have Mac and a bunch of different Linux flavors and Windows. So you can just download that, and I'll just show you actually really quick. I'm not going to do this way. I'll show you the other way. But let's so it will contain a few different things. This is the CLI that you'll end up running. You can run this install script, which will just move the Hub to your path. So you can just call Hub from anywhere on your computer. So that's one way to do it. The other way to do it is to build it from source. This is not always the best way to do it. Because if you build it from source, you may be using our latest code, which can sometimes get ahead of what we've released on the APIs. And so I'll go ahead and show you this anyway, and then I'll show you how to get back onto a production release, actually. So if I go ahead and clone that, and then we're gonna just jump in there. The way that you now install it is pretty easy. There's just a make file in here that makes all the methods pretty straightforward. You'll only be able to do this if you have Go set up on your computer. So again, if you haven't developed with Go and you haven't set Go up on your computer, definitely just go with the binary, install that. I recommend that for 95% of users, but I wanted to just show this for now. So I can just do make install, and it's going to go through the process of collecting all the correct dependencies for the library and downloading all those pieces, and then it's going to use Go to compile the binary CLI, and then it's going to finally move it into my path. So I'll have the Hub command available on my computer to start using. But again, this will be slightly ahead of the production APIs. So then I'm going to show you kind of what that looks like, and the command that you can use to just kind of always get onto the latest release, provided it works. Let me just go. This CD. let's go look in this one too, and I'll just try to do the same thing. So so now I should have a hub installed, okay, and I can just do which hub, and you can see that it's installed into my my Go path. And so if I do hub version, it's not gonna like, but it's fine with it, but it gives me this warning that I'm not running a production build. And so I should be able to run a hub update, and it should pull the latest version. But let me just show you actually this install. So this was the version I downloaded from the releases, and so I just call install on this. And now if I do which hub, let me just remove this guy. You can see that it put that release into my my binaries, so it's also available. And now if I go check out the version, okay, this is actually a pretty nice piece to work through. So on Macs, it doesn't like the fact that we're not signing these CLIs yet, which will fix that in the near future. But for now, you just need to say like, okay, well, I downloaded this from a verifiable source, which is our GitHub releases, so I'll trust it. So when you get this warning, and this is all in the documentation again, so in the installation stuff in docs, you can go read how to do this and follow it a bit more slowly. But you need to go into your security and privacy, and it's going to have this warning down here that says it was blocked, and you'll just tell it to allow it anyway. And then you're going to go ahead and you're going to try to run a command again. It's going to give you a final warning. This one looks a little different, just making sure you're sure you want to open it. And I'm going to say sure. And you can see now I'm running version 2.1. So cool. We're all set up. Let's start messing around with the buckets APIs. So the hub has a bunch of different stuff in it that you can use. You're going to need to actually create an account. So you'll call hub init. But I already have an account, so don't worry about that. Or I'm not going to worry about that today. But if you haven't done this before, you're going to need to go through the account setup steps, which again are all here. So you'll call hub init. You'll give it an email address. You'll verify that. There's also organization management. You probably want to do most of your work within an organization, and that's so that you can invite other collaborators to own and manage buckets with you. So again, all in the docs. And then there's a bunch of other things around PowerGate and Threads APIs. So let's take a look at the PowerGate methods, because a lot of this will be potentially very useful for people on this call. So I can see that. So it's called POW, hub POW, because it's actually passing you APIs directly from the PowerGate. So you can take advantage of a bunch of different Filecoin capabilities that the PowerGate enables with Lotus, and use those from your command line. You can also build them into your applications, and so I can just do. Oop, I need to give it an adder. Okay, so these are in autofill, so I'm not really a quadrillionaire or whatever, but cool. So definitely check out the PowerGate capabilities a bit more. I'm not going to get into that today, but they'll help you do a bit with the Filecoin network right away. So we're going to jump into buckets. So so I wanted to show you how to use some different data sets with a bucket. So why don't I go ahead and just create a new folder where I'm going to put my bucket in this folder. I'm just going to make a folder of shared images. And there's nothing in there yet. I'm going to go ahead and put some files in there that are a good example of a good example, or a piece of an example that I'll show you later that's a more complete use of buckets. So now I should have a few different folders. If you were part of the PowerGate masterclass, this is data that I was showing over there. That is a pretty fun data set, and it kind of matches the Slingshot competition type of data sets that you'll want to be bringing into Filecoin. But essentially, these are a bunch of scientific images of different shelled organisms, some different mollusks here. So these are the genus and species, and then each one has a bunch of various images. And so yesterday I showed how I collected and organized this data. I can go ahead and actually show that really briefly again. Let me go into yesterday's masterclass. And I'll check out my notebooks, and let's fire up my Jupyter notebooks. So, right. So I was saying in the previous masterclass that there's this step that I think everybody here will need to take, which is you'll have some data set that you want to be part of, this Slingshot competition, or that you're just building into your application, but you're going to probably need to do some processing to get it into a good format step, or format for the loading step. And so here I gave a good example of that, and I published this on Slack as well, so you can see this code. But basically this shell data came from a bunch of researchers, and I have the link online as well too. So it's presenting us with 60,000 images of 8,000 species. And when I downloaded this data here, it's actually a big flat list of all these images. And so I wanted to add a bit of structure to the images. They have a bunch of indices here as well that I didn't go into the process of loading those yet, but I wanted to load all of those images in a more structured format. And then I wanted finally to create a few indices of that data as JSON files. So what I do is I read through the full directory and I split up the names of the files. Let me show you an original name of a file. I don't have them handy, but basically it's like it's just a concatenated name that's like genus underscore species underscore some image identifier. And so I break those up, and then I create indices of the genus, indices of the species, and I nested that data into a bunch of folders that it's a folder for every genus, and then inside of that, a folder for every species name, and then finally the image index. And so here I'm going to show you, actually, why don't I replicate this a bit so I can show you something kind of cool here. So if I go in here to my shared images, I'm just going to create one more file, one more folder. I'm going to put everything in there because we're going to come back to this. So, okay, so I've got my shared images in here, and I'm just taking a subset so that we can load them pretty quickly for the workshop. But all right, so I'm in this folder with a bunch of those images, and now I want to create a bucket for them. So in the command line tool for the hub, there's the hub-buck commands, and it will give you a bunch of information here about the different commands that you can run. So the first thing that you want to do is you want to initialize a new bucket, and this is based on the current working directory. So that's why I've already CD'd into my shared images, and this is the folder that's going to become a bucket, and that I'll be able to push remotely. So to initialize the bucket, I just do hub-buck init, and I'll create a bucket called shells, and let's just make this not encrypted to start. And finally, I'll put it into, so this part, don't worry too much about this. You can just use the default in most cases, and that's to put it into the thread. So that means what thread you're going to kind of manage the metadata in. So there, I'm just putting it in a thread with all the rest of my demos. Cool. So now I've initialized it, and you can see it gave me back a bunch of links. And these are links that are corresponding to those different protocols that I mentioned before. And so on the hub, the hub has a bunch, the hosted hub has a bunch of different gateways for these different protocols. So you can go visit this this data set through any of those gateways. So if I want to, I can go check out the bucket here, which you can see has nothing in it yet. So so the bucket was initialized, but now I want to push this data remotely. So all I have to do is call hub buck push, and it's like I mentioned before, it's going to go figure out what this folder looks like and start creating the DAG. So here it's figured out what all the files are in that folder, says that there's 70 of them, and confirms that I want to push them. And now it's just going to go through the process of pushing each of these files remotely, and that's it. So just with that, we'll have our remote bucket. Now I moved this around a little bit at the beginning here because I wanted to show something pretty cool, which is now which I think is the way that a lot of projects for the Slingshot competition are going to be wanting to think about publishing data. So when I publish these images, they become a bunch of URLs, a bunch of IPFS hashes, but they're not meaningful. They're not really necessarily useful for people that might find them. However, in yesterday's masterclass, I showed an example where instead what I did is I created a bunch of structured data. So here are the full set of genus and species. And with that, I then also created a single page application, this index.html. And the indices that are created by that Python script before. And the index file can pull locally, the index.html can pull locally from these indices and populate a simple data visualization straight from the files here. I didn't get into any real data visualization. I just populate a table that is searchable and sortable and all that good stuff. And so the reason that's really interesting is that then anybody who ever accesses this data again has an interface that they can go explore the data. And I want to show that to you because I think that's the right way for many projects to be thinking about this. So after this completes pushing the 70 files, and my network's a bit slow right now because I'm running too many things, so that'll take a second. But after that's done pushing the files, I'm actually going to move this into my bucket as well, show you that diff step, push the diffs, and then we'll take a look at our bucket remote as well. All right, how we doing here progress-wise? All right, a couple more seconds on that. So then the next thing that I wanted to, let me actually just show you. Let me show you one other thing here. Okay, so basically, when I created this bucket, I created what is called a public bucket. When you create buckets, you can also create private buckets. And that's what I've done here. So let me just move this same data here. So this bucket, when I initialized it, I actually initialized it as a private bucket, which means all the data within it will be encrypted. And so if I do a hub buck push, it's going to tell me everything's up to date. Because if you remember, I just added these folders here, but when I started this tutorial, I had taken them right back out of here to populate my shared images. So I just added them back. So everything matches. So that's that step I was talking about, diffing. So while we're waiting for this one, maybe I'll do a little diff example over here. And that's pretty easy. So here's the bucket that here's my encrypted bucket that I'm mentioning. And if I go ahead and add a new file here, and I go and try to do, if I try to push this bucket again, see, it's detected that there's just one file different. And so, interesting. So it doesn't like that. So basically, if you've used Git at all, that's a really, this might look familiar. And it's basically saying, The bucket that I pushed remote doesn't match the working directory that I'm in. These trees have diverged too much to understand. And so what I can do is a hubbuck pull, and I think it's going to make me force it because that tree doesn't match. So let's just take a look here. My network is chugging along today. All right, let's actually just stick to this first one for a second. I'll go back and show you. I'll show you this in a minute more. So, okay, so we've successfully pushed all of these images in our shared images example. Now, if I go back to the published bucket, let me just pull up the links. If I go to this web page version of the bucket, there's no web page in there. It's just a folder with some images. So instead, I need to go to the thread URL, which will be a navigator here. And you can see that all my files have successfully pushed to this remote bucket as well. And so I can drill into any of those and just pull up the image directly. Now, what I mentioned before is that, like, if anybody else found this data as part of the Slingshot sort of competition, it's useless. It's just a bunch of images. So why don't we add this little UI that I created the other day that will also publish an explorer for this data at the same time. So I'm just going to move this into here. This isn't, I mean, I'll publish this all online. It uses a little data table method and loads the indices of all these files, and then we'll let you visualize it as a website. So if I go to Hubbuck push again, it's telling me that there's 7 new files. So it's just going to quickly upload those. And so once that's up to date, the thing that's going to change is I'll have all my files, plus I'll have this little web app that then I can render over the web. And what's really cool, like I keep mentioning, is that anybody who later comes to this bucket can also render this over the web. So again, there's nothing in this bucket that can render it as a web page. So using this website URL, it's going to come up blank until this application completes its loading. And I want to also bring up the thread-based link, because we'll show you all this data in there in just a second. Cool, I think that's it. So if I refresh that, you can see, cool, here's my bucket now full of files. And if I go to the website URL, you should see this be able to load. And we can see that here as well. Oop, I think I broke things. Oh, great. I broke my web app. No clue what I did there. Let's take a look. So it seems to be something with it not liking the jQuery loading. So maybe it just can't find it yet. Maybe this just hasn't completely refreshed. Huh. Okay. Okay, hates it. I'm going to skip this for now. There's something kind of funky going on here. Right. Okay, anyway, I'm going to move on, because the thing I really want to show you here is pretend that file worked fine, because what we want to do now is get it onto Filecoin. And I can show you another example of this working just async. I'll share it as part of the results of the workshop so that you can explore what I mean by pushing the application with your data. So the final step that I want to do is I want to get this on Filecoin. And so I'm already in the bucket folder. And so there's a command for buckets called archive. And archive will create an archive on Filecoin. This is the snapshot of this bucket right now. So if I create this deal, or if I start creating deals on Filecoin for this bucket, and then a month from now, the bucket has changed significantly, I may want to go and create a new set of storage deals on Filecoin to get the latest snapshot stored there so I can recover it later. So there's a bunch of interesting commands associated with archiving. There's some around the config, there's some around info and statuses. And so a quick tour of those, if I just do Hubbuck archive default config, it's going to print out a bunch of information about how this data is going to be stored on Filecoin. This isn't something that that you need to modify. These defaults are set up specifically for Slingshot. So when you start archiving buckets, they will immediately be part of they'll immediately be formatted and stored with the correct miners to be part of the Space Race Slingshot competition. But I just want to show you this because in the future, especially after mainnet launch, this will expand and be available for you to modify and tweak based on where and how you need your data stored. And so that would include things like creating whitelists or block lists of miners, having specific country codes that you want to find only miners in those countries, setting up how you want these archives to renew over time, and setting up what your max price is that you would pay to store that archive. And you can find all the information about these configs in the PowerGates documentation. We'll move a subset of this over to bucket documentation soon. But this all comes straight from PowerGate. So if you take a look, the config that this is actually exposing to you is just the cold section of the storage config. In PowerGate, there's a concept called hot storage, and that is IPFS. With the Textile Hub, buckets are always part of hot storage, so you don't need to tweak that. So it just exposes the cold storage, and you can read about each of these fields here to learn more how this is going to happen. So, and then the next thing that I wanted to show is just about the Hubbuck archive status, and this is something that we're going to come back to in a second, because there is no status right now. Same thing with info, should be pretty empty because there's no archiving happening. So the final thing that I want to do here is actually create my first Filecoin deal. I think I just call archive. And what's going to happen is it's going to use that config. It's going to fire this bucket off to a PowerGate using my Filecoin address. And it's going to kick off a bunch of deals with different miners around the world in order to archive and store this bucket on Filecoin. So if I proceed, all of that's going to start kicking off. Now, one caveat here is that our sort of Filecoin portal, the PowerGate and Lotus nodes running on the hub are just getting slammed right now with people testing the Filecoin network, which is awesome. But we've implemented a queue in order not to overload our network connection there. And so that queue is growing at the moment, and we'll work on setting up new nodes or setting up different ways to improve the flow of this queue. But right now the queue is pretty long, and creating deals on Filecoin is pretty long itself. So connected to get an archive of your bucket from IPFS all the way onto the Filecoin network can take upwards of a couple days right now. So just be aware of that. Fire your archive. Be patient. Now you just need to wait for it, and it will get there. And if I call info, you can see it's not been archived yet. If I call status though, it'll just tell me to be patient, and I can come back and call status again and kind of watch this flow go forward, and all the logs kind of fill in as the different steps of negotiating with different miners and then closing the different deals. But like I said, we'll work on improving this queue speed. So you should start seeing status changes more quickly over the coming weeks. But then the deal flow itself is always going to be kind of slow, upwards of, I think if it jumped right into the queue now and started making deals, it would take upwards of 8 to 10 hours just to move through the process of sort of negotiating the deal is quick, then moving the data to the miners can be quick or medium quick, but then the miners need to get it into their storage sector, seal the data, confirm that it's stored, and that can take 8 to 10 hours. So even to pass the queue, it will take time. And that's it. So with that, once this is done, my data set and my images all exist on the Filecoin network, which is super cool. Let me. I'm just gonna do this really quick to see if we can do one other thing. So I just removed the bucket metadata from the folder. So now hubbuck commands won't know that this is an existing folder, and I can just create a new one. And I don't think I'll have time to push this before the end of the workshop. So I realized the reason the web app wasn't working is because this was an encrypted bucket. So those links weren't working because they didn't have the ability to pull open the encrypted data. But if I had just made it, open, all of these files would have worked. And so once this is done pushing, I'll share the link to this bucket in our Hubbuck users Slack, and you can all check out what it looks like to have. I'll share all these links so you can see what it looks like to have a remote bucket that has the data, plus has a little web app, plus has the ability to browse that data with an application and UI that's published with it on IPFS and pretty shortly on Filecoin. So with that, I think that's kind of a basic tour of buckets and the things that you can do. I mentioned that you probably want to make buckets with organizations, and you can invite collaborators to buckets. So then you can be doing polls, you can be having multiple people adding data to buckets. And I didn't get at all into how you can use this with JavaScript in your applications, but we have a bunch of great examples and documentation online for you to check out there. So with that, I'm gonna just take 1 minute to answer any questions if there were any, and then I'll set you all loose because today in 5 minutes there's an office hours that I'm sure a lot of people want to take part in, which is the Lotus office hours, and so they'll be helping a lot of you figure out some of the core Lotus things, and I don't want to get in the way of that. So I don't see any critical questions here, which means all of you should join the Slack channel and get us your questions after this call, and we'll be happy to take them over there. So let me just share that one more time. Here you go, bucket users on the Filecoin Slack, and let me just, if you're not part of the Filecoin Slack, it's just you just go to that URL first, get onboarded to Slack, and then join our bucket users channel. And you can do these Hubbuck push. You can start doing Hubbuck archives, and you can start getting your data onto the Filecoin network in just a matter of minutes, really. Oh, actually, we might successfully have this. We might successfully have this web app up. If you give me 1 more minute, I'll show you what this looks like at the end of the day. So I think we have just 6 more images or 6 more files to push, and there should be pretty quick ones. So let's go back up to the top of all these pushes and find that URL again. Where was it? Okay, many files. All right, skip that. Okay, cool. There they are actually. So, all right. So this case, I pushed a non-encrypted bucket, which is handy if you want it to publish as a web app. So if I go to this thread again, you can see it's all the same data, but here it's not encrypted, which is handy. So I can go into here. I can see any of my images again, but like I said, I can now use the HTML to render and explore this data directly, which is super cool. And again, I didn't do any complicated data visualization here. I just created a table that lets you search and filter this data so that you can find any of the 60,000 images. You can visit those images and and take a look at what they are. And now I could build on this original data set and use any of these other indices to build a great little data visualization. And this is excellent for the Slingshot competition, because now you can hand this over as not only the data set being on Filecoin, but a simple user interface for people to explore the data. And if you build those indices in, it might actually be useful for people, and people can verify what each of these data points are on the IPFS network as well as on Filecoin. So that's the complete idea here. So hopefully that helps out people, and I'm gonna leave it there for the day. One last question is on size caps. So I don't recall total file size cap, but I think it's only limited by the size of the buckets, which are currently capped at 4 GB per bucket. So you need to create multiple buckets if you are trying to store data sets that are larger than 4 GB. You'll need to break that data up. And then I think files are only limited to that. And so when you push a file, it's gonna stream it, and so it'll actually be broken up over the API, but you'll just be limited to the bucket size. And so that was the last question. So with that, everybody should go check out the Lotus office hours and have a great day.